Hey, how's it going, everyone? Welcome to this video. We're just going to have a look at what's called Newton's method. So basically, it's an iterative method for obtaining numerical approximations to the roots of equations of the form f of x equals 0. Now, I'm not going to go through um, the method of how they worked it out, but essentially we get this nice big formula here in the white. So we've got x of n plus 1 is going to be equal to xn take f of x over f dash of x. Doesn't make much sense at the moment. It will as we go through an example. So this is example 8. We've got use Newton's method to calculate the root of the equation x cubed take 2x take 2 equals 0. That lies near the point x equals 2, expressed to 4 decimal places. So we say we've got f of x equal to x cubed take 2x take 2. Then our derivative of f of x is going to be 3x squared take 2. Now, from this formula here, we've got our x of n plus 1 is going to be x of n take our original function over the derivative of the original. So x of n plus 1 is xn take the original function over the derivative. Now, we can say x is going to be our initial point, x naught, which is f of x naught over f dash of x naught. And we can say x naught is going to be this point at 2. So our next point, x1 we'll call, is going to be 2 take f of 2 over f dash of 2. And what do we get on the top? Well, f of 2, 2 cubed is 8, take 2 times 2, so 4, take 2 is going to be 2. And our derivative at 2, 2 cubed, or actually, yeah, 2 squared is 4, times 3 is 12, take 2, so 10. So over here, I can say 2 take 2 over 10. If I work that out, I get 1.8. So x1 is going to be 1.8. And so I can do the same thing again. I've got x2 now, because I used x1 before. Well, that's going to be the previous term, which was x1, take f of the previous term, f1, over the derivative of f1, x1, sorry. So we have 1.8 take f of 1.8 over the derivative of 1.8. Now we're getting quite messy. You can do that in your calculator. And we get x2 is equal to 1.769948. Okay, so I'll put a roughly estimate. And we can do that again. So x3 is going to be the previous term, 1.7 699, take f of previous term over the derivative of the previous term, and we get this continuing cycle of terms. So x3 is going to be 1.7692, and we can keep going. x4, again, you can use the previous term, and we get 1.76929. And so both x3 and x4 are basically the same for the desired degree of accuracy, because we wanted 4 decimal places. Okay, here's our decimal places. So to 4 decimal places, the solution x cubed take 2x take 2 equals 0 is going to be 1.7693. So that's using Newton's method. So it's just using our formula, it's the previous term, etc. Okay, so that's it for chapter 13.4. Thanks for watching.